Hello students, we are solving the IB Math AHL past paper questions and currently we are solving the IB Math AHL May 2021 paper 1 time zone 1 past paper and we are solving one question every day. So today we will be solving question number 12, the last question of this paper, and you will be getting the links to all the previously solved questions in the description area in the playlist. Okay, so without any further delay, we start with our today's session, question number 12. Maximum mark is 20 and it says, let f of x be equal to square root of 1 plus x for x greater than negative 1. And subpart A says, show that the second derivative of f of x is equal to negative 1 over 4 times square root of 1 plus x to the power of 3. Okay, so we have to differentiate f of x twice, f of x equal to square root of 1 plus x. So we start with subpart A, f of x was equal to square root of 1 plus x for x greater than negative 1. So if dash x, that is the first derivative of f of x, will be equal to, this can be written as, because in calculus we do not use the surd form, we always convert it to the indices form, exponential form. So we write this as 1 plus x raised to the power of half. And now we are differentiating this expression, so the power will be coming down and 1 plus x will get raised to the power of the original power minus 1. And finally, 1 plus x should be differentiated, which is equal to 1. So if dash x, or the first derivative of f of x, is equal to half times 1 plus x raised to the power of negative half. Sorry, my throat is giving me some problem today. I'm sorry. So half times 1 plus x to the power of negative half is the expression for f dash x. The first derivative, we have to get the second derivative. So now it is half is the coefficient, so it should be written first of all. Then the power comes down. Now the power is negative half. And then 1 plus x will get raised to the power of the power minus 1. And derivative of 1 plus x is 1. So this is negative 1 over 4 times 1 plus x. Negative half and negative 1 when added, it gives us negative 1.5 or negative 3 over 2. So this can be written as negative 1 over 4 times, since it is the 2 in the denominator, so it will be a square root, and because it is having a negative index, so I can bring this down. Because of the 2 in the denominator, it becomes the square root, and I have brought the expression down because of this negative sign, and it is 1 plus x raised to the power of 3. So this is the expression of f double dash x. shown. Coming to subpart B, it says use the mathematical induction to prove that the nth derivative of f of x equal to negative 1 over 4 to the power of n minus 1 times 2n minus 3 factorial over n minus 2 factorial times 1 plus x to the power of half minus n, and for n belonging to the set of integers and n is greater than or equal to 2, and it contains 9 marks. So subpart B, we have to use the mathematical induction method to prove this. So we start with the line let P of n be equal to, I'm just copying whatever is written, I'm just copying. N should be greater than or equal to 2 and n is an integer. N minus 3 factorial over n minus 2 factorial times 1 plus x raised to the power of half minus n. Since the smallest value of n is equal to 2, first of all, let us get P of 2. So, P of 2 is equal to, n is equal to 2, so wherever I am having n, I will be putting 2. This is equal to negative 1 over 4 raised to the power of 2 minus 1, then 2 times 2 minus 3 factorial over 2 minus 2 factorial times 1 plus x raised to the power of half minus 2. Okay. So this is equal to what? 2 minus 1 is 1. So this is equal to negative 1 over 4. Negative 1 over 4 raised to the power of 1 is negative 1 over 4. And for the factorials, 2 times 2 is 4. 4 minus 3 is 1. 1 factorial is 1. And the denominator is 2 minus 2, that is 0. 0 factorial is also 1. And 1 over 1 is 1. So I'm not writing this part. Coming to 1 plus x raised to the power of half minus 2. So this is half minus 2 is negative 1 over 1.5. So it is 1 over x. Negative 1 over 1.5 means negative 3 over 2. So this can be written as negative 1 over 4. And since it is having a negative power, I can bring this down, and because it is having a 2 in the denominator, so it will be the square root of 1 plus x raised to the power of 3. This is equal to f double dash x found in the putty. So therefore, if P of 2 is true, because this is the expression, first expression, this expression we have got just by substituting 2 in the place of n wherever we are having n. This is the given expression in the question. So the first form is got from the question, and this, the final after simplification, and we are seeing this is exactly the form of the second derivative of f of x that we have found by actual differentiation. So P of 2 is true. Therefore, P of 2 is true. Next, let P of K is an integer, K is greater than or equal to 2. Be true. So P of K is what? P of K is equal to negative 1 over 4. Or first of all, let me write this as f, the kth derivative of f of x, equal to negative 1 over 4 raised to the power of n minus 1. So it will be k minus 1. Then it is 2k minus 3 factorial over k minus 2 factorial. I'm showing you. We are putting in k for n, so it is k minus 3 factorial over k minus 2 factorial and times 1 plus x raised to the power of half minus k. So 1 plus x raised to the power of half minus k is true. Let this be named as equation A. Okay, so therefore pk plus 1 should be equal to the k plus 1 derivative of f of x. Wherever we are having k, I'll be substituting k plus 1. Okay, so this is the expression got from the given question. This should be equal to 1 over 4 k plus 1 minus 1, and this will be 2 k plus 1 minus 3 factorial over k plus 1 minus 2 factorial times 1 plus x raised to the power of half minus k plus 1. So let us just simplify this a little. This will be equal to negative 1 over 4. K plus 1 minus 1 is k. And this is 2k plus 2 minus 3. 2 minus 3 is minus 1. So it will be 2k minus 1 factorial over 1 minus 2 is minus 1. So it is k minus 1 factorial and 1 plus x half minus k minus 1. So half minus 1 is minus half. Okay? So I can write this as minus k minus half. This is obtained from the expression. This let me name this as equation B, and this is obtained from the given expression. of the nth derivative of f of x. Okay. Now we will be getting p of k plus 1 by differentiating this p of k. Because p of k is the kth derivative of f of x, we will be differentiating this to get the k plus 1 derivative of f of x. Okay? So, on differentiating, we get p of k plus 1 equal to the k plus 1th derivative of f of x. First of all, we will be writing the coefficients. So it will be 1 over 4 raised to the power of, this is the equation A, raised to the power of k minus 1. The coefficients will be written, should be written first of all. And the power, the factorials were 2k minus 3 factorial over k minus 2 factorial. So k minus 3 factorial over k minus 2 factorial. And then 1 plus x raised to the power of half minus k. But half minus k cannot be written. First of all, half minus k was the, it's the power, is the power. This part contains x, so I have to bring down the power first of all. Half minus k. All of them are multiplied in fact. Half minus k, and then 1 plus x raised to the power of half minus k minus 1. And on differentiating 1 plus x, we get 1. Okay. So now let us simplify this a little. Let us see how much can be simplified. So this is negative 1 over 4 the power of k minus 1. We cannot do anything. Let it stay like this. In fact, we cannot, only thing that we can do is half minus k minus 1. This can be written as negative half negative k. Otherwise, we will be eliminating this one. We do not have to write 1 anymore. So this is the only modification that we can do. And okay, let us not write anything. Let us not try to simplify this part because we cannot do much to it. But what we need is this. This is p of k plus 1, this expression b. We need to get this expression b. In this expression b, we are seeing the negative 1 over 4 is getting raised to the power of k. But over here, we are seeing negative 1 over 4 is getting raised to the power of k minus 1. So we will be separating these. We keep it as negative 1 over 4 to the power of k times negative 1 over 4 raised to the power of negative 1. Okay, because it is raised to the power of k minus 1. So I need only the k, so I have kept one part as negative 1 over 4 to the power of k, and the other part is written as negative 1 over 4 raised to the power of negative 1. Okay, now coming to the factorial part. This is the expression b. It is 2k minus 1 factorial in the numerator. Over here, we are seeing 2k minus 3 factorial is in the numerator. So how can we get to 2k minus 3 factorial? We know what is the definition of factorial. It is factorial n is, if I write over here, n factorial is, we start, since it is n factorial, we start with n. Then we just go on decreasing the numbers by 1 at a time, -1. Okay. So n, then the next number will be n minus 1, the next number will be n minus 2, and so on. The numbers will be just going on decreasing in steps of 1, and we will be stopping when we reach 1. This is the expression, this is the definition of factorial. So 2k minus 3 factorial is 2k minus 3, will be starting with 2k minus 3, 2k minus 3, then 2 times by 2k minus 3 minus 1, which is 2k minus 4. Next number will be 2k minus 4 minus 1 will be 2k minus 5, and we will be continuing till we reach 1. Yeah. And we need 2k minus 1 factorial, because in expression B we have 2k minus 1 factorial. But 2k minus 1 factorial, instead of starting from 2k minus 3, we will be starting with 2k minus 1. So 2k minus 1, next number will be 2k minus 1 minus 1, that is 2k minus 2. Next number will be 2k minus 2 minus 1, that is 2k minus 3. And then again 2k minus 3 minus 1 will be 2k minus 4, and so on. So in addition to all the numbers that are present in 2k minus 3 factorial, we need two more numbers to be multiplied. They are 2k minus 1 and 2k minus 2. If we just multiply these two numbers with 2k minus 3 factorial, we get 2k minus 1 factorial, and we will be doing that because we need 2k minus 1 factorial. Okay, so 2k minus 1 and 2k minus 2 and 2k minus 3 factorial. This is the numerator. Go to the left a little more. Not sure whether you are being able to see the whole thing. Okay, so this is the numerator, but since I have multiplied the numerator with k minus 1 and 2k minus 2, I have to multiply the denominator also by the same numbers. So I have 2k minus 1 and 2k minus 2 in the denominator as well. And coming to k minus 2 factorial in the denominator. And what is the denominator of the expression B? It is k minus 1 factorial. So I need k minus 1 factorial. I am having k minus 2 factorial. Therefore, I have to multiply this k minus 2 factorial with k minus 1 so that it becomes k minus 2 factorial. Okay. So I will be multiplying k minus 1 in the denominator to get k minus 1 factorial. And since I am multiplying k minus 1 in the denominator, I have to multiply k minus 1 in the numerator as well. And this is half minus k. I can write this as, I can take the common denominator as 2, and it will be 1 minus 2k. Okay, and this is 1 plus x raised to the power of negative half negative k. What is the power over here? Okay, this is the same. Negative k, negative half. We don't have to modify the power. That is good. That is good. So negative k, negative half. Okay. Let me just erase this. Fine. And now we will be simplifying. This is negative 1 over 4 raised to the power of k. And this will be what? Negative 1 over 4 raised to the power of negative 1 is negative 4. Okay. And this part will be 2k minus 1, which we needed. K minus 1 factorial. And this is this extra thing, k minus 1. And in the denominator, we needed k minus 1 factorial. So we are having k minus 1 factorial. The extra parts are 2k minus 1 and 2k minus 2. So instead of 2k minus 2, I can take out 2. Why am I taking out 2? Because I am having k minus 1 in the numerator. If I take out 2, I can cancel these 2. So these 2 will be getting cancelled. Okay. And then I am having this part, 1 minus 2k over 2 and 1 plus x raised to the power of negative k negative half. Okay. So, and we are having this 4 in the numerator and we are having this 2 and this 2. So they can cancel. We are currently having the minus 1. Okay. And over here, this is 2k minus 1 and this is 1 minus 2k. So negative of 1 minus 2k will be 2k minus 1. Okay. So this can be written as negative 1 over 4 to the power of k, 2k minus 1 factorial over k minus 1 factorial times k minus 1. And this will also be 2k minus 1 because negative of 1 minus 2k is 2k minus 1. And 1 plus x to the power of negative k negative half. These two will be getting cancelled and we have pk plus 1 equal to the k plus 1 derivative of f of x equal to negative 1 over 4 to the power of k, 2k minus 1 factorial over k minus 1 factorial times 1 plus x raised to the power of negative half, negative k negative half. Okay, so this was equation or expression B. Let this be expression C. The expressions of pk plus 1 in B and C match. Therefore, we may say, or we have shown, that P of 2 is true and if P of k be true, where k belongs to the set of integers and k is greater than or equal to 2. Then p of k plus 1 is also true. Okay? So, by mathematical induction, we may say the nth derivative of f of x equal to negative 1 over 4 to the power of take one more. What was the a? Negative 1 over 4 to the power of n minus 1 times 2n minus 3 factorial over n minus 2 factorial times 1 plus x raised to the power of half minus n most probably, but let us verify it. Where is it? Okay, this is this. Half minus n. Or let me show the question as well. Half minus n. Okay. Half minus n is true for n belonging to the set of real numbers and n is greater than or equal to 2 is true. Okay. This completes our subpart B. So this is the subpart C of this question. It starts with let g of x be equal to e to the power of m times x, where m is a rational number. Consider the function h defined by h of x equal to f of x times g of x for x greater than negative 1. It is given that x squared term in the Maclaurin series for h of x has a coefficient of 7 over 4. The question is find the possible values of m and it contains 8 marks. And this is the expression for f of x. This was given at the very first part of this question, question 12. F of x was equal to square root of 1 plus x for x greater than negative 1. And f double dash x was of this expression, f dash x. If we need f dash x, I'll be getting the f dash x expression as well. But the Maclaurin series of h of x. Let us first of all write the Maclaurin series of h of x. So, of h of x will be equal to h of 0 plus x times h dash 0 plus x squared over factorial 2 times h double dash 0 means this is the first derivative of h of x, this is the second derivative of h of x, and x equal to 0 plus x cube over factorial 3 h triple dash 0, and so on. Okay. So, and they are saying that the coefficient of the x squared term. So which one is the x squared term? This is the x squared term. And it has what is the coefficient of x squared? It is h double dash 0, means the second derivative of h of x when x equal to 0, and divided by factorial 2 means divided by 2. This is the expression for the x squared coefficient of the x squared term, and this coefficient is equal to 7/4. But first of all, let us get the expression of h double dash x, where h of x is equal to f of x times g of x. Okay. So h of x is equal to g of x times, or it was first f of x was written, so let me write f of x. Both are the same, but since they have written f of x first, let me write f of x first. F of x times g of x. So what is h dash x, the first derivative? It will be, we will be using the product rule. So it will be f dash x plus, not plus, times g of x plus f of x times g dash x. Okay, this is the first derivative. And now coming to the second derivative. The second derivative, we are having two terms and we will be using the product rule for each of them. So taking the first term, it will be f double dash x times g of x plus f dash x g dash x plus, now the second term, f dash x g dash x plus f of x g double dash x. Okay. Now we need h double dash 0. So it will be h double dash 0 will be equal to f double dash 0 times g of 0. And you see f dash x g dash x, and this is also the same, so I can just add these. So it will be 2 times f dash 0 times g dash 0 plus f of 0 times g double dash 0. Okay, now we have to get the values of these. Let us go to the expression part. G of x, it is g dash x should be equal to, n will be coming down, m times e to the power of mx, and g double dash x will be, again m will be coming down, e to the power of mx. Okay, so we need g of 0. So g of 0 is, m times 0 is 0, e to the power of 0 is 1. G dash 0, e to the power of mx is 1, we have seen. M times 1 is m. And g double dash 0 is equal to m squared times 1 is m squared. We have to find the possible values of m. M is a rational number. What about the f0? We have to get the f dash as well. So let us get the expression for f dash x. This is 1 plus x whole raised to the power of half. So half will be coming down, and 1 plus x raised to the power of half minus 1 is negative half. Okay? So now we can get f of 0 is 1 plus 0 is 1, square root of 1 is 1. If dash 0 is actually f dash 0 is 1 plus 0 is again 1. 1 to the power of negative half is also 1. Half times 1 is half. If double dash 0, 1 plus 0 is 1. 1 cube is 1. Square root of 1 is 1. So negative 1 over 4. Okay. Let me write the g values also over here in the same line. G of 0 was equal to 1, g of dash 0 was equal to m, and g double dash 0 was equal to m squared. Okay. Let me write the same line. Dash 0 was equal to m, and g double dash 0 was equal to m squared. Fine. And now, first of all, we have to get h double dash 0, and we have to divide it by 2. First is f double dash 0 times g of 0. G of 0 was equal to 1, and f double dash 0 was equal to negative 1 over 4. Okay? So negative 1 over 4 times 1. Negative 1 over 4 times 1 plus, hope you can see this, plus 2 times f dash 0, g dash 0. G dash 0 is m, and f dash 0 is most probably half. Yes. Half. So it is half times m plus f of g0, g double dash 0. G double dash 0 is m squared. F of 0 is equal to 1. One times m squared. So this is equal to m squared plus m minus 1 over 4. And the coefficient of x squared should be equal to coefficient of x squared is h double dash 2 over 2. So therefore, over 2 means I can multiply by half. Half times m squared plus m minus 1 over 4. This is equal to 7 over 4 most. Yes, it is equal to 7 over 4. So this is equal to 7 over 4. Now it is a quadratic equation we have to solve. And we cannot use the calculator because it is a paper 1 question. First of all, let us multiply the entire equation by 2. M squared plus m minus 1 over 4 is equal to 7 over 2. And then let us Let us multiply the entire equation by 4 so that I get rid of this. So it is 4m square plus m minus, 4m minus 1 is equal to times by 4. So this 2 and that 2, 4 will get cancelled. So we'll be having 7 times 2, which is 14. This is equal to 4m square plus 4m minus 1 minus 14 is minus 15 equal to 0. Okay, can we factorize this? 15 times 4, so it is 2 times 3 times 5. We have to get 4, so 5 times 2 and 2 times 3. 10 minus 6. 4m square plus 10m minus 6m minus 15 equal to 0. Or I can take 2m common. It is 2m plus 5. And from here I am taking minus 3 common. It is 2m plus 5 equal to 0. Therefore, 2m plus 5 and 2m minus 3 is equal to 0. So, m is equal to either negative 5 over 2 or m is equal to 3 over 2. M is a rational number, they have said. So, m is either equal to negative 5 over 2 or m is equal to 3 over 2. Okay? So we have completely solved this question number 12, and this was the last question of this paper. From tomorrow, we will be starting with the paper 2 time zone 1, May 2021 past paper. And I am Nilanjana Sanyal, and I tutor students from IB Math E, SL and HL students from India and outside India. And I'll be starting with the new batch of online math tutoring sessions for IB Math E, SL and HL from the month of July 2023, obviously. And if any of you are interested in joining my classes, please write to me. You are seeing my email ID, my WhatsApp number. These are getting displayed. So you may contact me, you may mail me, you may text me if you are interested in joining my classes. Okay? And thank you for staying with me till the end. We meet again tomorrow with a new paper. So till then, bye.